Hello guys, I'm Wahida from University Malaysia Pahang. Welcome to Signals and Networks course. This is Module 1, Part 2 on title Signal Elementary. Before we start, do you still remember what is signal from previous video? Yes, signal is variables that carry information. In this video, we are going to discuss more details on continuous time signal. Let's take a look at several types of signals. They are unit steps, impulse response, sinus and exponential complex signal, unit ramp, sinc function, rectangle function, triangle function, and signal function. First, unit step function. The notation of unit step is UT. The unit step function is defined by UT equals to 0 for t less than 0 and UT equals to 1 for t greater than 0. It is called unit step because the step is 1 unit high in the system. It represents a signal that switches on at a specific time and stays switched on indefinitely. The second and third figures shows the shifted version of unit step. Next is unit impulse. The notation of unit impulse is delta t. The unit impulse function is defined by one impulse signal at t equals to 0. Other than that, the unit impulse equals to 0. A system impulse response is defined as the output signal that results when an impulse is applied to the system input. One way of introducing the unit impulse is to define it as the derivative of the unit step function. Next type of elementary signal is sinusoid and complex exponential. Sinusoids and exponential functions should already be familiar. A sinusoid is a signal that has the form of the sine or cosine function. The general expression for sinusoid is Ft equals to A sine omega t plus theta and Ft equals to A cos omega t plus theta. While the expression for complex exponential is Ft equals to A exponential j theta, or it is equal with A cos theta plus j sin theta, where this is the Euler's formula. From all the equations of the sinusoid and complex exponential, A is the amplitude of the sinusoid, omega is the angular frequency in radian per second, where omega equals to 2 pi over t, and theta is the phase. Sinusoids and exponentials are very common in signal and system analysis. Other than that, unit ramp is one of the elementary signals. The unit ramp function is the integral of the unit step function. We can define unit ramp as ramp t equals to t for t greater than 0 and 0 for t less than 0. It is called unit ramp function because for positive t, its slope is 1 amplitude per time unit. Next, sinc function. Sinc function is the mathematical form of the sine of a quantity t divided by the quantity itself, where sinc Ct equals to sin t over t, where t is the quantity. This function occurs often enough in Fourier analysis. Here is rectangle function. Function as a switch to turn on and turn off any equipment in a specific time period. The definition of rectangle function is rect t equals to 1 from negative half to half of t and 0 for others t. It can be represented as combination of two shifted unit step signals. Rect t equals to u t plus a minus u t minus a. This example shows how the combination of two unit steps can representing the rectangle function. The first signal, which is the top one, is a shifted unit step ut plus 1, while the second signal is another shifted version of unit step ut minus 1. Subtract the first signal with the second signal will produce the rectangle function ft. Look at time t less than negative 1. The amplitude of first and second signal are 0. Because of that, the signal ft is 0 for t less than negative 1. Now, look at time range between negative 1 and 1. The amplitude of first signal is 1 and the second signal is 0. So, 1 minus 0 equals to 1. Therefore, we draw the amplitude of the signal ft in between time range negative 1 and 1 is 1. For t greater than 1, both signals' amplitude are 1. 1 minus 1 equals to 0. Then we draw the signal ft equals to 0 for t greater than 1. Next elementary signal is triangle function. The definition of unit triangle is triangle t equals to 1 minus modulus t for modulus t less than 1 and 0 for modulus t greater than 1. Modulus t means that it can be negative or positive t. It is called a unit triangle because its peak height and its area are both 1. The last elementary signal we are going to discuss is signum function. We define signum function as for non-zero of t, the magnitude of signum function has a value of 1 for t greater than 0, and the magnitude of signum function has value of negative 1 for t less than 0. This is the equation of the signum function, and this is the graph of the signum function. The signum function also can be generated from unit step function. Here are the examples. We have two examples here. First is signum t equals to negative 1 plus 2 ut, and the second example, signum t equals to ut minus u minus t. This slide discusses about the examples. If we have a constant negative 1 added with a unit impulse, where the amplitude of the unit impulse is double, perform the addition. For t less than 0, the value are negative 1 plus 0 equals to negative 1. For t greater than 0, we have negative 1 plus 2 equals to 1. Therefore, ft is a signum function. Second example shows the operation between two unit steps as well. The first one is a unit step, and the second one is the reversal version of unit step. Perform the subtraction to both of the signal. We get for t less than 0, the value are 0 minus 1 equals to negative 1. And for time range t greater than 0, we get 1 minus 0 equals to 1. Therefore, this ft is a signum function as well. Okay guys, now you already know about elementary of signal. Hope you enjoyed the lesson. More example in the next video. See you again. Bye.